Okay, let's go over the test. The first problem, we're supposed to determine whether it has a horizontal or oblique asymptote and determine what that is. So we got to look at the degrees. The degree of the numerator is 2. The degree of the denominator is going to be 2. And so if they're equal degrees, then it's y equal the ratio of the leading coefficients. The leading coefficient on the numerator is the -2. The leading coefficient in the denominator is going to be x times x. It's going to be 1x squared, so it's -2 to 1 or -2. Second one, the degree of the numerator is 2. The degree of the denominator is 3. The denominator is going to grow faster than the numerator, making the fraction go towards 0 as x gets very large. And the last one, the degree of the numerator is greater than the denominator by 1. So it's going to have a linear oblique asymptote. And so we're going to do long division to find that. 2x plus 1 divided into -5x squared plus 3x plus 10. So 2 goes into -5, -2.5 times, and x into x squared takes an x. So if I take that times 2, I get -5x squared. And if I take 1 times that, I get -2.5x. Then I'm going to draw the line and change the signs and add like terms. These cancel out. This comes out to be 5.5x plus 10. And all I need to know is, what do I have to multiply 2 times to get 5.5? Would have to be half of 5.5, which is plus 2.75. And that will be the oblique asymptote. Okay, down here, to find the numerator of the equation, this happens to be a rational function, there's going to be an a that I got to figure out. But the numerator is based on the zeros and the x-intercepts, and there's one at 1. So that means there's x minus 1. And it went straight through, so it's to the power 1. And it looks like it bounces at 4. So there's going to be an x minus 4 twice. And that looks like all of them that I see. One there and a bounce there. So that's 3 of them. And it looks like the horizontal asymptote might be maybe a little off at 0, maybe 0, I'm not sure. But the degree of the denominator is at least equal to the numerator, degree 3, maybe more. So it looks like we have going in the same direction. This one's angling more than this one, so it's going to be favoring this side. So I'm going to say it's probably at x equal -1. So I'm going to say a factor is x plus 1. And it's got to be squared because they're going in the same direction. And this one looks like it's favoring, this is steeper than this side, so it's probably favoring 3. And they're both going the same direction, so I'm going to guess it's x minus 3 squared. And if that's the case, then I should be able to figure out the coefficient using, I see it goes through 0, -4. So I've got to come up with -4 when x is 0. So there's something here, A, I can call it, and I got to put in 0, which is, that would be negative 1 times 16, so negative 16 over, if I put 0, I get 1 and 9, so 9. So if I multiply both sides by 9 and divide both sides by negative 16, and then simplify, see, a minus and minus will cancel, 4 goes into 16 4, so it looks like 9/4. And I could write it in the numerator, 2 1/4. That should be pretty close. Let's see how that looks. So, yeah, okay. Go to y equals, and I'm going to type in 9 parenthesis. Well, I better let's clear and make it a fraction. In the numerator, 9 parenthesis x minus 1 close parenthesis and parenthesis x minus 4 close parenthesis, and that one's squared. In the denominator, I have a 4 parenthesis x plus 1 close parenthesis, that's squared, and a parenthesis x minus 3, and that one's squared. And let's go zoom. Let's see how far. Zoom. We'll try zoom forward to start with. And that looks pretty darn close to what we got. Okay. Number 2. All right, to do this one, we need to type in the numerator so we can factor. So it's 2x to the third plus 7x squared plus 2x minus 3. Make sure I've typed it right. 2x to the third plus 7x squared plus 2x minus 3. Yes. All right, so I'm going to graph that. Looks like it goes through minus 3 straight through, minus 1 straight through, and a half. So I'm going to guess it factors to x plus 3, x plus 1, and x minus a half, or 0.5. And there's a leading coefficient. You've got to get all the pieces. Get the leading coefficient and the factors that are shown on the calculator. Now I'm going to turn that one off by going to the equal sign and pressing enter, and type in y2, the other one, which is x to the third plus 5x squared plus 8x plus 4. Graph. And that one looks like it bounces at negative 2. So that's x plus 2 squared. And it goes through minus 1, so x plus 1. And the leading coefficient's 1, so we're okay there. So there's it factored. Any holes? Well, I have these look-alike factors, so there must be a hole at negative 1. And to get the y-coordinate, we put negative 1 in for all the x's. So I'm going to get 2. Negative 1 plus 3 is 1. And I forget this. I can't put it in for that, so I'm using it in the simplified form. This over that, or this and this over that. So I got to put minus 1 in there, which makes this minus 1.5. And minus, this has got a 1, and then a minus 1 in there is 1 squared, which is 1. So I get 2 times 1.5, negative 1.5, which is 3 over 1. So I get 3. Now, let's see if that looks like it's anywhere close to correct. So I'm going to go to the graph, and I'm going to turn that one off, and I'm just going to type in y1 divided by y3. To do that, I'm going to go vars, var variables, y1 divided by vars, y variables, y2. And that should be the graph of this. And I should see a hole at -1. So I'm going to put in second, calculate the value at -1. And it's going to say not a value. So that confirms that we got the hole right. Is it at -3? Let's see. If I push trace and I'm at -1.1, I'm at -7. And at -0.9, I'm at -4. So I'm off a little bit. What did I do wrong? So, here's what it is. 2 and -1 plus 3 is 2. So it's twice as much. It's at -6. 2 times 2 is 4, times 1.5 is -6. Good thing I checked it. Determine the vertical asymptotes and the behavior. Well, there's one at -2. X equal -2. We write it as an equation. And it's a squared, so they go in the same direction. As the graph gets close to -2, they go in the same direction. You can see that here. They go in the same direction. The horizontal or oblique. Well, our degree in the numerator is 3 and the denominator is 3, so it's a horizontal one at 2 over 1, or y equals 2. And if I want to see it here, I can go down and put another one in here, y equals 2, and graph, and it's getting closer to 2 and closer to 2. I can see that I've got it correct. X intercepts and behavior. Well, that's determined by this. There's one at -3 straight through, and at +1/2 straight through. At -3, 0, and 1/2, 0, and both are, for the behavior, straight through. What happens when x gets very large? It approaches the horizontal asymptote. It approaches asymptotically, if you will, y equal 2, or it snuggles up to y equals 2. Determine the y-intercept. That's easiest up here. If I put 0 in for all the x's, that's -3. 0 in for the x's, I get 4, so it's -3/4 when x is 0. It's a point, so we got to write it as a point. Any local maxima. Well, if this is snuggling up to the line here, it must go up and then come down. This one's going up, so it looks like there's going to be a local maximum somewhere in here. So if I push trace and move over there, it looks like it's around -5.2. So I'm going to go second, calculate the max. That's somewhere between -6 and -5. And my guess is going to be -5.5. And it says, oh, it happens at negative 5 1/3 approximately, but the max is 2.45. Local maximum of 2.45. Is there a local minimum? It goes up and then goes down to infinity, comes back, and never has a low spot that goes down and comes back up, and so there are none. And when is this graph 0 or less? The y values for what x's are the y's less than or equal to 0? Well, the y values are less than or equal to 0 between -3 and -2. And at -3, it's equal to 0, so I can keep it because it's got equal 0. -2 goes off to negative infinity, so we can't include it. And remember, there was a hole at -1, so we have to go union from -2 to -1 where there's a hole, and then after -1 it continues being negative, less than 0, up to a half. Union from -2 to 1/2, and including the 1/2. Kind of tough one. You can't see the hole. That you got to remember that there is a hole. Oh, from -1 to 1.5. From -2 to -1, and from -1 to a half. Page 3. Cube root, so the minus comes right out. 24 is 2 times 12, which is 2 times 6, which is 2 times 3, and x, 5 of them, 2, 3, 4, 5, and 2 y's, and we're taking out groups of 3, so I got 3 2's, comes out, 3 x's come out, don't have to worry about absolute value on an odd root, and I got an x squared and a y squared still in, and a 3 still in, so I got the cube root of 3x squared y squared. Even roots. Now I have to worry about absolute value. We got looking for pairs. There's a pair of x's that'll come out. So this part is -2 absolute value of x square root of 3. 12 is 2 times 2 times 2. 2 times 2 is 4 times 3. X, 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 x. And there's already a -2 out. And I'm looking for pairs. There's a pair of 2's. A 3 will stay in. And there's a pair of x's, and pair of x's. 3 pairs, so that's x to the third. That's an odd number, so I have to put it absolute value. These are not identical, so I can't do anything with it, and so I'm just going to say -4 absolute value of x to the third square root of 3 minus 2 absolute value of x square root of 3. If there is something I could do, you don't have to do this on this. This could be absolute value of x times x squared. This would always be positive, and that would make it positive. So there's an absolute value of x and a square root of 3 in both terms, and a -2. So I could factor that out. I could go -2 absolute value of x square root of 3 times 2x squared. That's what would be left here, taking a 2 out of that. And here there would be -1. So I could factor it like that, but this is fine. This says I have 2 of these, and I'm going to take the cube root. So I'm going to do it with the root sign first. Cube root of 9, which is 3 times 3, and I have 2 of those, so another 3 times 3. I have x to the 5th, 2 of those, so I got x, 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 and another x, 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 x. And I got y to the 4th twice, so y, 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 y. And now I'm taking the cube root, so I'm doing groups of 3. So there's a 3. There's a group of 3. Another group of 3, and another group of 3. 1 left. So I got a 3 left, an x left, group of 3, another group of 3, and a y squared left. Now, if I did it with powers, I can say 3 squared x to the 5, y to the 4th, all multiplied so I can distribute the power. So I can take 2/3 times 3, so 2 times 2 is 4/3, 3 to the 4/3, 2 times 5 times 2 is 10/3, x to the 10/3, y to the 8/3. So that's 3 to the 1 and 1/3, x to the 3 and 1/3, and y to the 2 and 2/3. So I got 3 to the 1, x to the 3, y to the 2, 3 to the 1/3, so there's one of them under the cube root, 1x under the cube root, and 2 y's under the cube root. Now, if I don't write it with a cube root, it would be 3x cubed y squared, and then 3x y squared to the 1/3. Or I could distribute and have 3 to the 1/3, x to the 1/3, and y to the 2/3. Okay, let's do this one. 8, 4, and 16 are all powers of 2. So 1/8 is 2 to the negative 3. 4 is 2 squared, and that's to the 3x plus 2. And 16 is 2 to the 4th, and that's to the 2x minus 3. So I've got 2 to the negative 3, 2 to the 6x plus 4, and 2 to the 8x minus 12. So here I add the powers because we're multiplying. So we got 2 to the 6x plus 1. And so I can, now that I got a single base and a single base, they're both the same, the power, and they're equal, so the powers must be the same. So I got 6x plus 1 has to equal 8x minus 12. I'll subtract 6x, add 12 to both sides, divide by 2, and I'll check my answer. So I'm going to go 13 divided by 2, store in x. So it now thinks x is 6.5. And if this is correct, I can go 1 divided by 8 times 4 to the parenthesis 3x plus 2. And I can do the other side, and I should get the same number. 16 to the parenthesis 2x minus 3. And I got the same number. So using 6.5 for x, this side equals that side. So that's the correct answer for this problem. Now let's do this one. An even root, fourth root, so the inside has to be greater than or equal to 0. I can only do even roots of 0 or positive numbers. To solve for this, if I subtract 2 from both sides, I get negative x greater than or equal to negative 2. And if I divide both sides or multiply both sides by a negative 1 to get rid of the negative on the x, I have to remember to flip the sign. And so from negative infinity up to 2 are the numbers I can use in this, including the 2. So if I put 2 in there, 2 minus 2 is 0, and the fourth root of 0 is 0. So that works. And I should work for numbers less than 2, like 0. 2 minus 0 is 2. Fourth root of 2 I can do. It's not a pretty number, but it works. Cube root. Cube root can do the cube root of anything, so this is all reals. It's an odd root. How much remains after 3 hours? We got this bacteria population. So I put 3 in for the t's, and I get 3,000 times 3, which is 9,000, over 9 plus 15 is 24, and that is 9,000 divided by 24, 375 bacteria. And how much is expected to remain after many hours? So what happens in the long run on this? What's the end behavior of this? The degree of the numerator is less than the denominator, so this will go to 0. So it will, f of t, the population, will approach 0.